Hello, my name is Melinda Higley, and I'm an assistant professor of geology at Calvin University. I'm going to present recent results from a project called Geophysical Investigation and Subsurface Characterization of Lake Michigan Coastal Landforms. Coastal sediments along Lake Michigan typically consist of sandy deposits that overlie glacial and lacustrine sediment. Historically, increases in lake level have caused shoreline transgression and erosion of coastal sediments, like dunes and bluffs, often accompanied by landslides. 2019 and 2020 has been no exception. Lake levels have been above long-term average, and extensive erosion has occurred around the Lake Michigan basin. Although communities are grieving major losses of infrastructure, one outcome of this erosion that is positive for science is the exposure of fresh faces of some of these coastal sedimentary units. For example, in this drone footage from Berrien County in southwestern Michigan, landslides have exposed at least two different sedimentary units in this bluff: the tan sandy unit above and the gray fine-grained unit below, as well as vertical and horizontal variability within those units. Erosion and bluff failure present an opportunity to collect information about the sediments and sedimentary units that are failing. So this summer, Calvin University students and I conducted geophysical surveys on coastal areas that have been prone to erosion. Our goal was to map the internal structures of the eroded landforms. I'll show you two of our study sites. The first one is a dune scarp at Hoffmaster State Park, south of Muskegon. We used a geophysical method called ground penetrating radar, or GPR for short. The researchers are standing on a dune scarp, and they ran a GPR survey from right to left, going parallel along the shoreline. We are currently learning the range of things we can do with this equipment. So it's important to compare something known, in this case, that's the exposed dune scarp, to the directly adjacent subsurface patterns that we can see in the GPR data. These black and white lines are the data. They're called reflections. We interpret these reflections as the layering of the dune sand. Because when comparing the data to the exposure, like comparing these yellow boxes, we can see the same structure pattern. It's not just a homogeneous pile of sand. The wind has deposited this dune in distinct layers. The GPR data collected by going across the scarp confirms that this structure is actually internal to the dune. In fact, these are previous surfaces of the dune. And we know this because the surfaces can be traced laterally going uphill in GPR data that you can see in Peter's presentation. Our second study area was a failed bluff at Hager Beach Park in Berrien County in southwestern Michigan. From this view, we can see the landslide in our study area, as well as the exposed sandy unit above the fine-grained unit that is so common along the shoreline. The cliff face at the landslide site was covered in the slump of this sandy unit, and the contact between the fine-grained unit and the sand is obscured. But we confirmed that it was down there. Then we did a GPR survey going across the top of the bluff, this time perpendicular to the shoreline. This slide is arranged to show you the GPR data and the bluff picture side by side. Where the scan ends on the left is where the cliff was. We can learn something about the sediment by direct observations and sampling, but something we can uniquely see in this GPR data is the topography and slope of the contact between the fine-grained unit underneath and the sandy unit above. This is delineated by the yellow dashed line. It appears to slope upward as we go away from the cliff. Also, since the contact is obscured by the slumped sediments on the cliffside, we can get a good idea for the thickness of the sandy unit from the GPR data. Looking closely at the sandy unit, we observe that it's actually sand and gravel, and a possible interpretation is that this is glacial outwash. So that's denoted here. It's likely that the gravel layers are providing the nice contrast that makes these strong GPR signals really pop. From our work this summer, we can conclude that direct comparisons between the GPR data and the visible sediment layers will aid in the interpretation of the extent, thickness, and topography of unstable sediment layers, especially in situations without direct access to the sediment. Thanks to NASA, MSGC, Calvin University, Hofmaster State Park and Ottawa County Parks, and Berrien County Parks for funding and opportunities.